Good morning, it's Monday morning, a couple of minutes to 6. Some of us have got sleep problems and mental health problems when we're up early, because the brains are lit. So, just thought I'd do a little video on ignition faults on boilers. I think first and foremost, it's important, especially for beginners, that you understand the process of combustion, because you need three main components for combustion for the boiler to light. So let's use the back of this cylinder. Combustion process, you need three components. One is a fuel. In most cases is natural gas, so we'll just put NG there. Another component is air, oxygen, and the third component is ignition, a source of ignition, a spark that's hot enough and long enough. If you take any one of them components away, you're going to have an ignition fault of some sort. It's not going to work. So that's your combustion process. Those are the three components that you need, which is CH4 plus 2O2 burnt off equals CO2 and 2H2O, if I remember correctly. So that's your combustion process there. Those are your fuels going in. Methane, CH4, oxygen, 2O2 produces CO2, carbon dioxide, and water vapour, which is condensation. That's complete combustion. Remember that, that's important, because if you haven't got those, then you're bringing up other faults and dangerous appliance. And then incomplete combustion would look something like this: CH4 plus, so you've got two oxygen molecules there. So if we change that to 1.9, simple as that, that's going to give us incomplete combustion. So those are the three main components, and it's important that you remember them all the time, all the way through your fault finding. Remember, you need those three things. If you haven't got that in your head, you're not going to find an ignition fault at all. So let's have a look at a boiler. Just swing this out of the way. So I've got a few boilers there. Okay, so a few things you're going to need first and foremost for working out ignition faults. You're going to need a gauge of some sort. So you've already got your manometer, traditional manometer. I prefer the Premier U gauge. Gas analyzer can be used for reading pressure inputs, or something like the Testo, Smart Pros. Those are really good. I've had those for years. Can do a version, I think TPI do a version as well. You're also going to need a multimeter, and I use needle. I don't know if you can see them. Very fine needle Test Pros. I find them are good for getting to your little connections, especially in circuit boards. And also I carry a pair of voltage testers, so I generally use them a lot more than I do a multimeter. If it's straight AC voltage and certain DC voltages, I'll use that. If I want to get a true reading, I'll use that, my multimeter, and also for testing resistances and stuff, you use your multimeter. So let's look a little bit about this ignition fault that we're going to talk about. So going back to what we just said about the three things that you need for ignition, which is gas, a source of ignition, and also oxygen, air. So first we're going to look at Okay, so it's important to remember when you're starting a breakdown, or when you're looking at repairs on boilers, always start at the start of the process. A lot of people just lose their way and they jump in halfway through the process and miss some of the start of it. So, for example, we're going to look at an ignition fault. First thing you want to do is ask the customer what's going on. Ask them some questions. If there's a pattern to it, is it just straight ignition fault all the time? Does it light? Does it go out after a certain time? Is there a time of day that it's playing up on? And we're going to be measuring, just remember this, that your gas ignition fault starts from the service in the ground. So there could be a fault anyway along that fault up to the gas meter, all the way to the boiler, that's going to cause that fault. So first and foremost, you want to be putting your gauge on P1 of the gas valve and running it through its ignition sequence. And then just seeing if there's any movement at all in that gauge. So you will see, let me just grab it. So we've got this, imagine we've got this connected to P1. We're going to have a standing gas pressure there. When that gas valve opens for ignition, we're going to see a movement in the gas valve. If it goes down to somewhere like that, we've got an issue. It should not be doing that. It should be dropping just a couple of millibar, maintaining a working pressure of around about, you know, textbook is 20 millibar. Very rare you get that in today's installations. Obviously we've got condensing boilers going on there, which for a lot of gas to start with. People don't upgrade gas supplies, so you find the inlet working pressure to the boiler can be quite low sometimes. Obviously, if you check the manufacturing instructions, you'll have minimum working pressure at that appliance. So, I always find personally, when I'm looking for an ignition fault, that using a gauge like that or a water gauge is far more responsive than using an analyzer. Whether it be one of these is a Riazzi. I've got Kane as well, I've got Testo. They all seem to lag a little bit, the analyzers do. However, the Testo Smart Pros are a lot faster. They do respond a lot quicker. So, the reason I like using one of these is because if you're going through an ignition sequence and you've only got, say, a 5 second to 10 second window of spark and gas being drawn into the burner, if you're waiting for that analyzer to settle and drop down in digits, you can miss it sometimes. So this, it's almost instant, it drops to where you need it to be. Another thing to be aware of is these gas valves generally open quite quick, so you'll notice a movement on the gauge quite quick. If they're struggling to open, so it's a gradual opening of the gas valve, sometimes that can suggest a fault as well. So, first and foremost, when you turn up on your ignition fault, try and fire the boiler. It's important to see at what point of ignition the boiler fails at. So that's all we're looking at in an ignition fault is we're trying to work through the process of fan's going to run first to purge the heat exchanger. That's going to be proved on this boiler by its pulse width and modulation sensor, which is going to be back down to the circuit board. So we know the fan's run, purged the heat exchange of any products of combustion or anything that was left in there, ready for a source of ignition and then new burner to fire. So what's going to happen on this boiler is it's a pre-mixed burner, so it draws air in through there as well as gas, which is blown up into the burner. Okay? So if you remember, the three things that we need is gas, air and a source of ignition, right? So on this particular, that's going to be a low voltage air, if I remember rightly. So we want to know, if we go, let's work down the gas route first. We need to know the gas valve opens and we've got voltage to it. So we measure that from P1 of the gas valve. And we'd also take a voltage reading from there, if it's readable. Obviously every boiler is different. Some gas valves are easy to get to, and take a reading. Some are more difficult, and sometimes you have to take a reading from the circuit board itself. However, personally, I always try and get my reading from on the gas valve itself, because it proves that my harness is okay as well. So let's say, for example, we've got voltage to this gas valve. We've got a gauge on P1, which is there. Gauge on P1, and there's no movement on that gauge, so we've got 21 millibar standing pressure on that gauge, for example. And then boiler tries to fire, we've got voltage to the gas valve, that doesn't drop at all. That's going to suggest we've got an issue with the gas valve. Again, different model boilers, different gas valves, you're able to take a resistance reading across pins on the gas valve. Let me see if I can dig one out and show you. Okay, so this is just a gas valve off another boiler. It's just easy to show this example. So certain boilers, the pins are more available to get readings from, so you can take resistance readings across those. Those resistance readings will be listed in the manufacturer's instructions. If you haven't got them to hand, you can go on the gas app, find the instructions on there. If you still can't find them, phone the manufacturers. Don't be scared to phone the manufacturers and ask them for help. Just remember, they're your best friends and they're there to help you. That's exactly how I learned how to fix boilers. Nobody ever showed me how to fix a boiler. I literally just taught myself and went out to boilers and spoke to technical helplines until I worked things out. So yeah, you take readings across certain points on your gas valve. That's another way of checking the resistance and proving that the gas valve is actually faulty. Another thing to look at on this gas valve, if you can see that there's like a gauze inside that gas valve there. And what can happen is, which I've had a few times, you get little bits of debris and shale in the gas valve. Just knocked a few tiny little bits out there. You get bits of shale in the gas valve, and that can block the inlet gas going in. So you can have the correct working pressure at the gas meter. You can have the correct pipe size all the way to the boiler, to the appliance, but still your inlet working pressure is low. That's going to suggest you've got some sort of restriction in the gas supply. So a good one to look at is always take your gas valve out, check the bottom side of it, which is the inlet side, and you'll see a bit of gauze there. Take it out, bang it, and you might see some debris drop out. That can drastically reduce the gas supply to a boiler or any appliance, but predominantly you're going to find on a gas valve, so have some protective gauze there to stop that from happening. So that's your gas supply. That's basically it. Have we got gas to the appliance? Yes. Is the gas valve opening? Yes or no. If it is opening and we've got gas flowing through, then we're looking at another fault. We know that the gas supply is okay. We've got enough gas going through it. Depending on what boiler it is, it could be that the gas valve is an adjustable gas valve and the high and low CO2 settings are out. So we'd start looking at other parts of the ignition sequence before we start messing with that gas valve then. So we've covered, have we got gas to the gas valve? Yes, we have. Is the gas valve opening? We've got voltage there. Yes or no will prove if the solenoid is working. So let's, for example, we've got voltage to that gas valve's opening, but we've still got no ignition on this boiler. So now we're going to move on to the other parts of that ignition process. Okay, so we've kind of covered the gas valve. It's important to remember that that solenoid can be slow opening. You could have an issue mechanically with the gas valve, so it opens, but it's just not opening fast enough. Just remember that. You're normally looking for a drop of a few millibars on a gas valve when it's opening. So, next on the process is spark. Have we got spark to the burner? So, what we can do is, on this particular burner, on this particular boiler, so we've got a spark generator up there. Some boilers, it just comes straight from the circuit board. Some of the earlier Worcesters, the juniors, it just comes straight from the circuit board straight to the electrode. There's not actually a spark generator on there as such, so you do the same sort of thing. What we can do is we can pull that lead off the spark generator and we can test the voltage going into there with your voltage testers. So that would just be a matter of putting the boiler through its ignition sequence, putting your test leads in there, running it through its ignition. That'll light up to 230 or whatever the voltage is supplying that spark generator. That information will be found in the manufacturer instructions or gas app, or again, phone the manufacturers if you're stuck. So you'll take a voltage reading from there. It's important to make note that that's got to be a constant voltage through its ignition process. So that should be constant for whatever the ignition process time is, 5, 10 seconds, whatever, and it shouldn't be dropping off at all. If it's dropping off in between, that could be where your problem lies. So we've confirmed we've got voltage to the spark generator. It's then about proving that the spark generator actually works. So ways we can do that: we can pull that lead off there, we can put electrically insulated screwdriver to it and see if it arcs from that terminal to the end of the screwdriver. We can also pull it off the actual spark electrode itself and do the same thing there. That will prove that our harness in between the electrode lead is okay. It's not uncommon for these to break down in certain positions and arc out somewhere. Make sure there's no damage on your leads anywhere. You can get an adapter, I think, fits between that and your spark electrode, and you can click it on and it will literally light up in the centre of it. I've never had one, I've never really needed one, to be honest with you, but it is a good little device. Okay, so we've proved we've got spark to that boiler now. We've proved we've got spark up to that point. We want to know that those are sparking inside and they're okay. So how can we prove that? We can take the electrodes out and we can look for damage across them. It's not uncommon to get little fractures in the ceramics down there, which can arc it out onto there. On particular models of boilers, some of the models like Baxi Solo plus HE, electrodes are on the front of there and there's a big insulation panel on the inside. If that insulation panel gets wet, that will also cause the spark to arc out against the water in the insulation panel. So we can take that out, we can inspect them, we can isolate the gas and we can run it through the ignition sequence and hold those and make sure the spark is a good strong spark and everything looks okay with the electrodes. One thing to note on nearly every boiler, if you're taking an electrode out, at the back of that there's going to be a gasket. That gasket can need replacing, so you're going to have to bear that in mind when you're taking stuff out. Is it safe when you're putting it back in? Have you replaced the gaskets? So let's say we've proved we've got spark now, everything's okay. We're happy that the gas valve's opening correctly. We're happy that we've got good spark there. We're now going to be looking at some sort of air restriction somewhere. On a lot of the Worcesters, they've got a bearing plate, which is like a little rubber flap that opens. They're normally above the fan there. It's only on Worcesters you're going to find these. You don't really see them in any other boilers. So what we're going to be looking at is there any blockages in the venturi, air intake at all? Is there anything in there? Is the burner okay? Is there any damage to the burner? Is there any blockages in the burner anywhere? Is the heat exchanger mucked up? Obviously, when this boiler is manufactured and designed, it's designed so it's got enough volume of air inside there for combustion. If that starts blocking up, you're just restricting the air inside the heat exchanger. If you're restricting the air, you're going to get incorrect mixture of combustion. So what people tend to do sometimes is they come out to a boiler that hasn't been serviced a lot. It's got a gas valve that's an adjustable gas valve. So they start coming along and tweaking the gas valve and tweaking it, trying to get less gas into the burner so they can get the boiler to fire up, because they'll have a gas-rich burner. The reading's going to be off the scale, it's going to be noisy, and it's going to cause an ignition fault. And in the end, it's just going to cause problems with the boiler. So we're going to look at the burner for damage. Again, on this boiler, you've got to remember that seal's got to be replaced. A lot of the boilers on the market. Okay, So with this boiler, remember there's a burner seal on the top there that's got to be replaced. If you're going to check that, you want to be looking for damage. These are a fabric burner, if I remember rightly, downward facing. Check for damage. If I'm honest with you, I don't think I've ever had a fabric burner damaged on a Worcester Bosch. Burners on Ideals, what do? They have spot welds that come away inside and they cause a vibration noise. Most people say that's down to the spot weld. I generally find that vibration noise from the burner is down to a block burner itself, not the spot weld itself. You'll also get the gas valve on this particular boiler causing the exact same fault. So it's easy to work out sometimes if you've got enough gas going into it, or it's an airflow problem or so on and so forth, is when it's going through ignition, if it won't light, you can simply restrict the airflow a little bit, see if that will light. Same on that boiler there, that's your Venturi, there's your gas injector there. If you put your thumb over there and restrict the airflow, it'll cause the boiler to light sometimes if you're having issues with gas supply or air circulation faults. You know where you're looking, then you know that you're on like some sort of restriction somewhere, or the gas supply is being restricted. So every boiler is different, but the same process applies to every single boiler. Have we got voltage to the gas valve? Is the gas supply correct to the gas valve? Is it passing through the gas valve? Is the gas valve opening cleanly? Have we got voltage? Have we got spark to the ignition on this one? As you can see, this is an intergas. Spark is generated off this little box on the side of the gas valve, which goes up there to the ignition electrode on the top of the burner. Navion over there. On the front there we can see. The same process applies to every single boiler. You're always going to need the same components for that boiler to work. You're just working through at what point is this boiler failing. So a lot of the boilers on the market, you can just take them apart and put them back together and inspect everything. Another thing to note as well is if we've got a detection electrode. So on this Ideal boiler there, we've got a detection electrode. There's a little hole in the back of it. That's a test point to put your test probe from a multimeter down to another point and take a reading to make sure that detection electrode is giving out the correct reading when it's sensing the flame. Again, those readings can be found in the manufacturer instructions. If you can't find them in there, phone the manufacturers and let them walk you through how you test through the ignition sequence. But those are the main characteristics of what you're going to need to work through an ignition sequence and find it. Don't be afraid to take that boiler apart. Ideals can come apart without replacing any seals. Just check them, they do stick on the back edges. If it fractures, it's got to be replaced. Worcester Bosch can't take it apart without replacing any seals. Intergas can be taken apart without the seal being replaced, although it should be replaced every 3 years. They tend to go on the top right edge there. Navion boilers, you'll never need to take that heat exchanger apart. If it is, it's a bit of a big job. You just go to the manufacturers and they'll come out and resolve that. Wiesmann boilers can be taken apart without replacing the seals. Quality heat exchangers. Valiant can't be taken apart without replacing the seals. Let's just get this off the top of here. Same again, Valiant boiler. This one's got a mass airflow meter on this, which is just the airflow going in. Same process applies. Different boilers, you can see different setups. Hard to take readings from stuff. There's your electrode, same applies. You can pull that off there, stick an electrical screwdriver in between it. Another thing that will also cause ignition faults is if you've got flue seals that have gone. So if that's damaged there, if you're not getting fresh air coming in for combustion, basically, it may work for so long and then it'll go off and cause an ignition fault because the air's vitiated. You've got no fresh air, so the gas burner will start lifting off and searching for oxygen, then it'll come off the electrode there and cause an ignition fault. Another thing, which is a common thing on boilers to cause an ignition fault, is a block condense. So the traps block up down there, that blocks up there, or the condensed pipe leading away from the boiler is actually blocked. So generally, how we approach these is take the trap out, we'll clean the trap out, we always blow down the pipe. We've got a little pipe that we connect onto it and we blow down that pipe to make sure that's clear. Because what will happen is, as I said earlier, always ask the customer, is there a time, is there any patterns of this boiler going off? Sometimes engineers will turn up, the boiler will run fine, and that's because there's a partial blockage in the condensed pipe somewhere and they just haven't run the boiler long enough. And all that happens is the water backs up down the condensed pipe, backs up through the trap, starts backing up into the heat exchanger, and then it starts restricting the air inside that heat exchanger. So if you remember, you need 3 components for combustion. If you start restricting that air, then it starts becoming noisy. When it starts becoming noisy, you can have an unstable burner and it's restricting it, so it'll just blow it off the detection electrodes, and then it'll give you, on this particular boiler, it'll give you an L2 fault. So it's always down to those 3 things. Have we got gas? Have we got ignition? Have we got oxygen? And the ignition, the condensed backing up, is oxygen related. Although everybody thinks it's just water in there, it's actually starving it of oxygen. So hope that helps. Hope that helps some of you new guys. Obviously, you older guys should be have this nailed down, I would imagine.